Yes, welcome once again to my channel and welcome to optics part 5, and we will continue our discussion and we will learn about Fermat's principle and law of refraction. Okay, we will learn the relation between Fermat's principle and the law of refraction. Okay, as given over here. Someone was asking me that why do you think that someone watched my video and he was asking me on WhatsApp that why do you think that BJP is going to rule for coming 15 to 20 years. Okay, means you had said that BJP is going to rule till 2039. Why do you think so? Someone was asking me. The reason is very simple. You must have played PUBG, right? You must have played once upon a time PUBG. Okay, some of you might be playing now also. In PUBG there is something called as ESP hack. Have you ever heard of ESP hack? Have you ever heard of ESP hack? Yes. So in PUBG, if you have ever heard of ESP hack, then BJP has actually ESP hack. Suppose your playground of PUBG where 100 people are playing. That 100 people, suppose you are playing Irangal. And suppose that Irangal playground is suppose your election. Okay, so as soon as Modi ji enters the playing field, he has ESP hack with him. Okay, he has ESP hack. As soon as he applies that hack, every opposition leader is just destroyed. Okay, so they have basically hacked the democracy. Okay, democracy has been hacked in India. It has been hacked. Everything is biased nowadays. Okay, biased in favor of Modi ji. So that's why I had said that BJP is going to rule till 2039, because even the minds of people, okay, minds of not all the people, but minds of 30% Hindus, okay, minds of 30% Hindus has been hacked, completely hacked. Okay, mind has been hacked. And as the mind has been hacked, they will always vote for one party only. So based on only 30% Hindus, they can win up to 2039. Okay, so that is the thing. That's why I had said so. Okay, so Fermat's principle and law of refraction, we will learn about this. The N1 and N2 refractive indices of first and second medium. Suppose this is your first medium and this is your, I just talk like this in between so that you also come to know the truth also, because some people get very angry after I say that people are nowadays polarized, right? So people then those who do not like BJP just shout at me that why are you saying that BJP is going to rule till 2039. So I told that. Okay, so N1 is the refractive index of this part, the above medium, the medium above this mirror, and the medium which lies below this glass. Suppose this is not mirror. If it would have been a mirror, then it would have reflected, but it is a glass. Suppose glass slab. Suppose, okay, it is a glass slab. What is it? It is suppose a glass slab. Okay, glass slab. Suppose it is like that. And N1 is the refractive index of this part and N2 is of this part. V1 is the velocity of light over here and V2 is the velocity of light over here. And this is your distance x. Okay, OM is equal to your x. This is your this overall distance is equal to d. As this is x, so this will be what? D minus x. Okay, and this is I. This is angle of incidence and this is angle of refraction. Okay, so what has happened is that this and this are parallel, this and this are parallel, and this is your transversal. So this angle and this angle will be equal. Okay, this is your angle of refraction. This is this and these are parallel. This is your transversal. So this angle and this angle will also be equal. Okay, so that's why this is R and this is R. This is I and this is I. Okay, So Fermat's principle and law of refraction we will study. N1 and N2 refractive indices of the first and second medium. Okay, N1 and N2 refractive indices of the first and second medium. V1 and V2 speed in first and second medium. V1 over here and V2 over here. Okay. Time taken by light to go from A to B via O. Okay. So time taken by light to go from A to B via this O. So how does the light go from there? Suppose this is your AO. So AO divided by distance upon speed. V1 is the speed over here. So distance divided by speed will be your time in the first medium. So time in the first medium. Then distance upon speed in the second medium. So this is in the second medium. Okay. So overall time taken to go from A to B is like this. Okay. Now this is clearly, you know this very well, that your AO, what is it equal to? What is your AO equal to? This is A and this is X. So your, by Pythagoras theorem, AO is equal to square root of A square plus X square, right? And your OB is equal to what? Your OB is equal to square root of D minus X square plus B square, right? So it is like that by Pythagoras theorem. Simple. Now you know this very well, that in the place of AO I have substituted its value by finding out through Pythagoras theorem. In the place of OB I have substituted its value by finding out through the help of Pythagoras theorem. Okay. Now by Snell's law you know another thing. By Snell's law what do you know? V1 is equal to your C by N1. You know this very well. Okay. Velocity of light in medium 1 will be equal to velocity of light in free space divided by refractive index of the medium. Velocity of light in medium 2 will be equal to speed of light in vacuum divided by refractive index of the second medium. So those values I have substituted. This is also by Snell's law of velocity. Okay, so this is the thing which we have substituted. Okay. Now you know this na, okay, over here it is written. Okay, what I told you is written over here. Okay. Now this is your equation number 1, right? This is your equation number 1, and this is t is equal to f of x. Okay, t is equal to your, this is your whole expression. This whole expression is your f of x. Okay, this is your t and this is your f of x. Okay, so t is equal to your f of x. Okay. Now dt by dx, what will it be equal to? Dt by dx. Okay, just consider this, that dt by dx, when you find out the single differential, then what will it come out to be? This n1 and c will be outside. Okay, this 1 by c just take it outside. 1 by c just take it outside. N1 and n2 will remain over here. Okay, and it will be d by dx of this thing and d by dx of this thing. Okay. So after you find the d of dx of those two, d by dx of this comes out to be this, d by dx of this comes out to be this. Okay, so you found out that basically. So this is your equation number 2 basically. And after you see, look at this carefully, look at this and this carefully. This is basically, look at this triangle. How can you find out the sin I? Sin I is equal to your opposite divided by hypotenuse. So opposite is this, which is equal to x, divided by hypotenuse, which is square root of a square minus a square plus x square. Okay, so this is your sin I. Okay, and your similarly sin r will be equal to opposite, that is d minus x divided by hypotenuse, which is equal to this. Okay, so your sin r is equal to that. So this is your basically equation number 3. Okay, that 1 upon c n1 sin I minus n2 sin r, this is your basically equation number 3. Okay, so you got this. Now dt by dx you have already found out. Okay, dt by dx value you have already found out. Now we will find out that based on Fermat's principle, if we want to find out the law of refraction, which is the Snell's law, with regard to Fermat's principle, with the help of Fermat's principle we have to derive the law of refraction. Then what will we do? Suppose we have Snell's law. Okay, if law of refraction is true, suppose this is true. Okay, because from this we have to derive, that is we have to assume that this is true. So according to Snell's law, n1 sin I will be equal to n2 sin R. Okay, this is quite obvious from Snell's law, which you have already learnt in the 10th class. So as soon as you write n1 sin I equal to n2 sin R from this figure, as soon as you write that n1 sin I is equal to n2 sin R, as soon as you write that, what does it mean? It simply means that this dt by dx over here, these two quantities are equal, and as soon as those two quantities are equal, this will turn out to be 0. So your dt by dx becomes equal to 0. Okay, your dt by dx becomes equal to 0. So your dt by dx has come out to be equal to 0 from Snell's law. Okay, so from laws of reflection you have to find out Fermat's principle. So this is law of refraction, not reflection, refraction. Okay, so law of refraction is over here, and as soon as you put this value in that equation, dt by dx you get equal to 0, and as soon as you get dt by dx equal to 0, that means t is extremum from Fermat's principle. Okay, that means t is extremum. Okay, so this is from Fermat's. Now law of, just a second friends, just a second. Okay, yes, now law of refraction from Fermat's principle. First of all, we assume that law of refraction is true. What did we do in the first case? We assumed that law of refraction is true, and based on this we proved this. Now we will do the reverse thing. We will assume that this is true, and based on this we will prove law of refraction. Okay, so according to Fermat's principle, t is extremum, so dt by dx will be equal to 0. We are proving on the basis of Fermat's principle law of refraction. So as soon as you write dt by dx equal to 0, what do you get? You get n1 sin I minus n2 sin R will be equal to 0. Why? Because just put it there, na? Just put it there. Just put this value equal to 0 over here, and this c will go over here, and this will become 0. So n1 sin I will be equal to n2 sin R. So Snell's law has been proved. Okay, n1 sin I has come out to be equal to n2 sin R according to Snell's law. Okay, so this is the thing. So dt by dx is equal to 0. So n1 sin I equal to n2 sin R we have proved. So based on this we can reach over here, and based on this we can reach over here. Okay, so both are complementary to one another. As soon as you prove this expression, which expression? The expression on the previous page, this one. Okay, as soon as you prove this expression, you can prove that the both are complementary to one another. Okay, if the one is true, then another will also be true. The optical path during refraction at plane surface is minimum. Okay, now this is your homework. d2t by dx2, you have to find out you have to prove that this t will be minimum. Okay, this t which we have found out over here, this t value which has come out to be equal to this much. Okay, you have to simply prove, it is your homework, very easy homework, that d2t by dx2, just find it out. Okay, d2t by dx2, just find it out. When you find that d2t by dx2 out, you will find that as soon as you find its value, d2t by dx2 value, the thing is that you will always get it to be greater than 0. Okay, some expression will come which will yield you always greater than 0 value. Okay, by common sense you can judge that d2t by dx2 value will be greater than 0. And I had already told you in the previous lecture, when the double differentiation is greater than 0, when the double differentiation of a function is greater than 0, then that means that particular point is the minima of that function. Okay, so t is minimum at that point. Okay, so t is minimum, and path, that's why if the time required for traveling the distance is minimum, then the optical path will also be minimum, because when time is minimum, the path will also be minimum, because distance traveled is directly proportional to the time taken. Okay, so that is the thing. So d2t by dx2 greater than 0 you have to prove from home. How will you prove it? The way you had proved for the reflection. The way you had proved for reflection, in the same way you will prove for refraction also. The way you had proved for reflection, in the same way you will have to prove for refraction. Okay, in a reflection, what did you do? In reflection you had found out all those values. So in the place of refraction, just differentiate this expression once. So you will get d2t by dx2, and by common sense you will find that d2t by dx2 will always be greater than 0. You will get square quantities again. Okay, you will get all square quantities once again. So that is the thing, that's your homework. So what does it mean? that means that the optical path during refraction at plane surface is minimum. That means in the case of plane surface, the optical path during reflection also, okay, in case of plane surface, the optical path during reflection also and the optical path during refraction also, both reflection as well as refraction, during both the optical path at plane surface is minimum. Okay, in case of plane surface, suppose I have a plane mirror, and plane reflection. In case of mirror, reflection will take place, and in case of glass slab, refraction will take place. Okay, so as both are, glass slab is also flat surface and plane mirror is also flat surface, so in both these cases your optical path is going to be minimum, because the reflection and refraction both, okay, reflection also and refraction also, both at plane surface, during the reflection and refraction at plane surface, the optical path is minimum, or the time is minimum, you can say. Okay, but this does not hold good in the case of spherical surface. Over here it is plane surface, that's why it's always coming to be minimum. Over here it is plane surface, that's why in case of reflection also and in case of refraction also it is coming to be minimum in case of plane surface. Okay, but if instead of plane surface, if suppose we have spherical surface, instead of plane surface, then this condition will not hold. Okay, it will not always be minimum. It might be minimum also and it might be maximum also in case of spherical surface. Okay, got it? So this is the thing. So that's how you can find out this thing. Okay, so we will learn about chromatic aberration of a lens in the next class. Okay, so thank you very much. Hopefully you have got everything. If you haven't watched the previous lectures, then please go to the link in the description and start watching from lecture number 1 of optics. Only then you will understand everything. Okay, otherwise it will be very difficult for you to understand all these things. Okay, in the initial lectures I don't have PDF with me. In the initial lectures, as my pen tab was also not ready, and the laptop is also laptop has also got some fault in it. See, ever since I have updated the laptop, it is showing that it needs to restart. Okay, it has run into a problem, it is showing like that. So basically laptop I cannot use, but I will teach you on tablet all these days. Okay, up to the time when the repairer actually arrives at home. Okay, so that's the thing. So this is the thing which you will get from here. So hopefully you got everything. Chromatic aberration, which is chromatic aberration of a lens, we will learn in the next class. Thank you.